Let's talk about Firestore security rules so that we can start locking down our database so that only authorized users can access their data. I want to do a big parenthesis here because in reality, you should think about security rules before you even start building the code and storing the data. If you leave the rules open and trying to lock them all in the end, you'll certainly need to do some refactoring in your code to comply with the security rules and their limitations. So, if you haven't started building the app, that's great. Go through this lesson before you decide on a database structure. And if you're about to deploy, I'll give you some tips and workarounds if you cannot restructure your data. To access Firestore security rules, you can go into your project and in the Firebase console, you can click Firestore and where you're going to see your data, then you can click Rules and you're going to be able to open the rules as shown here. In the Rules tab, we have the ability to both write and test our security rules. They even offer a simulator when you can simulate actions here in Develop and Test for different users to make sure that the rules are working as you expect before deploying. When you first create an application, you start in development mode, which means that all of your paths are open by default. So as you can see here, we are starting in development mode. The rules you're going to be seeing are similar to this, or they will have something like they will be open for the first 30 days that you are playing around with the database. So let's try to first understand what's going on here. This line right here that says match document star star, this is telling our security rules that whatever is going to happen next is going to apply to the entire database. And this line allow read write if true is saying that we are going to allow read and write operations everywhere. Before we start securing our documents, let's first see how security rules work. First, let's explore how match statements work. The most basic representation of a match statement goes something like this, where you are matching the path to the database and the conditions to be able to read or write. Those blocks can be as simple or complex as your app needs them. For example, if your database only needs to be read or written by authenticated users, you can set up a global condition for that, and it will look something like this. It will say, okay, every document in the database is going to be allowed to read or write if the request.auth is different from null. Request is a keyword we have access here in the security rules where we are getting the request object. In here we can get the request.auth, this is the authentication, and the request.resource, this is the data that's coming inside of that request. This line right here that has the equal star star is a wildcard. It means that it will match to all of the paths in the database. Besides this, you can also match individual paths in the database. So for example, you can also do something like this. And you're going to say, okay, in the user ID path, I'm going to do this. In the documents, I'm going to do this, or whatever, something else, I'm going to do this. And this is a way to also separate the rules based on the structure of your database. And in this path, when we pass the name in curly braces, we are saying it's a variable. So if I have users 1 to 3 or users 1 to 4 or something like that, that rule will apply to all of them. Another cool thing to do here in the Firebase function is that you can also create functions. So if, for example, you find yourself asking for the requested user a lot, you can transform that into a function and you can say function is requested user, and then wherever you are doing the actual check, you can replace it with the function call. And you can see how you can add things like, okay, I'm going to add another condition, and that will apply to all of the path where we are using our functions. And lastly, before moving into the specific documents, you can also separate read and write conditions in their own lines. So if, for example, you want different conditions, if it's a read request, if it's a write request, you can specify it as granular as you want. So for example, they allow us to get both get and list. List is to get a list of documents from a collection, and get is to get a specific document from that collection. And the write operation, we can break it down into, am I creating the object, updating the object, or deleting the object? And we can set different conditions for each one of those. Okay, now to get into the specific of our database, for writing conditions go hand in hand with structure in your database. For example, the client SDKs are all or nothing, means that fetching data, if you want to get one document, you get the entire document. You cannot get partials. So, for example, if a document has 20 properties, you'll get those 20 properties back. You cannot tell Firestore, I only want this or that property. Because of that, it's a good idea to separate public from private information. For example, let's say you have a user's collection, and inside each user's document, you store their private API key, just to give you an example. Then the user document would look something like this. It has first name, last name, whatever other properties, and the API key. Now, the issue with that is that if you want your user to be able to see other users in the database, like for example, if they have a friends list, when you fetch the users, you'll get the name with the other properties, like that secret API key. For that, it is a good idea to separate that private information. So there are two ways to separate it. You can put it in a different collection or store it in the user's subcollection. If the information is only pertinent to the user, it's a good idea to have it in a subcollection. So instead, our data or our document would look more something like this. The base collection or the root collection of users has the first name and last name, and whatever private subcollection we have in the database has an API key. We can also represent that here in data. Let's say, for example, we have the collection users, and we have the first user, it has first name, and it also has last name. We save that, we go to the user, and inside the user document, we can start a subcollection, and this will be the private data, just to give you an example. And the first document will be the API key, and we can give the value of whatever it is we had there. With this, we can have the user's document with the public collection inside of the document. And then all of the private collection can be part of subcollections. This is because when you fetch a user, you only bring the root level document. You don't bring any of the subcollections unless you specifically call for them. And then having this kind of structure, we can go back to our security rules, and let's replace all of this. And we can say, okay, so I'm going to go into my database and I'm going to match the user's ID, and that user document is going to have these properties. So we are going to allow read or write operations if the user is an authenticated user. But that private subcollection, we call that private data, it's going to have a different rule. So we are going to allow read or write operations here if is same user. This is same user is a function. It's taking the user ID, and what it does is going to check, okay, is this an authenticated user? Yes. Then it's going to check, is the user making the request the same user of the document we are trying to get? If this matches, then yes, this is the same user profile, so it will get access to that part. Okay, let's say you want to add some more extra information to this, and that you want that not only is same user has access to this API key, but that you have a platform admin that you also want them to have access. You can do something like in your database, you can have a different collection. Let's call it platform settings. And inside of platform settings, we are going to have a document called admin, or this is going to be the ID of the document. And in here, we are going to add two fields. For example, this can be the UID, and this is going to be the ID of the admin of the platform. And the other one can be the email, and this can be like jorge@jsmobiledev.com. So now we have in a separate collection, we have the data for the platform admin. So now we can go back to our security rules, and we're going to add another function here. this function is going to be called isPlatformAdmin. And what this function is doing is saying, okay, first let's check if the request is there. So this is an authenticated user. Then it's going to use the get function from Firestore to get to that path. It's going to get to database, inside our database, platform settings /admin. And it's going to check if the data for that document has the UID property and that property is equal to the user making the request right now. Then that means that the user that's trying to access that document is our platform admin. We can add this isPlatformAdmin function here in the conditions too. So we're going to say this document is going to be available for the owner of the document or if we have the platform admin. Another thing we can also do is to base our rules on properties on the document itself. So for example, let's say we have another collection, and in that collection we want to see if we can read the documents. And we have public and private documents. So public documents are open to everyone. We can say that you can read or write to this collection if the data inside of the document is public. Notice that here we are using resource instead of request. That's because if we do request.resource.data, we are not really checking the data itself in the database. We are checking the object that's coming in the request. And since that request comes from a client application, you could modify it to have something else. So what we do instead is we say, okay, you are going to edit document, 1, 2, 3 in the database. So we are going to check not with the request you are sending, but we're going to check with the resource itself. So the actual document in the database. And these are all ways in which you can secure your data. But what happens when your database is ready and you cannot make any changes? Like your application is ready for production, you first built everything, and now you're trying to secure as much of it as you can. Like, I get it. I've been there in the past. If you don't think of security from the beginning, it makes things a bit more complicated, but not impossible. Let's say, for example, that you have your users stored a little bit like this. So you have a users collection and you have the user's ID and you have first name, last name, and role. Then, technically speaking, you could have security rules that look like this. And this looks okay. It says, okay, we are going to match the user ID if the user is the same user or if it's the platform admin, then you can let them read or write the user profile. So they technically work and can protect you from regular users, but as soon as a user wants to attack you, your app can be compromised. Why? Because the isSameUser function takes the user ID from the request. So it checks that it's the real user that's performing this request, that's performing the condition. But if I, as a user, have access to edit my user profile and the role is there, like nothing is stopping me from changing this user to a role of admin. And then the request will succeed and I will be given an admin role. For that, there's something we can do. Let me just move this over here and I'll explain it. So we can separate the rules. We can say, okay, we are going to allow you to read this document if you are the user that created this document. So if this is you, or if you are a platform admin. For creating the user profile, we're going to say, okay, only the platform admin. And you can see it says, is same user. It checks if the same user is the one performing the request. And isPlatformAdmin checks if the user has the role of admin. Then for delete operations, we're going to say the same. Okay, we want only platform admins to do that. But for update operations, this is where things change because we can say, okay, if did role change or is platform admin and we can check, as you can see, all of those rules right here. What is this did change role? This is a function. And this is something that Firebase lets us do. We can check the request and we can see the data inside of that request. This diff right here is going to check between the data that's coming in the request and the data that is currently in the database. And we have a changed keys function that let us check, okay, has any of the properties I'm going to say in this array changed? So has the role property changed? Is the role property that's coming in the request different from the one that's in here in the database? So if this is correct, like if the roles changed, it will break and it will create an error for the user and it won't let them change. So if the user updates their profile and they change their first name or last name, we are good. But as soon as they try to modify this role property, then it's going to throw an error and it won't let them perform the request.